The unit place can be filled by 0 or 5, which is in two ways, right? How many 4-digit even number can be formed from these without repetition? That is, no digit being repeated. If a number ends with an even number, from this means it should end with these 2, 4 and 6 only. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. So, in my previous class we have discussed a few problems on permutations and combinations in all type 1, 2, 3 and 4. Today also in this session I am going to take few more problems based on those types. Now in the previous class we have studied regarding arrangement of peoples and the books, and when repetitions occurs, when repetitions do not occur. So these are the few concepts which we have studied in the previous class. Now in this session, so I am going to take few more problems based on this. Now first, type 5, formation of number with digits with repetition. The formation of digits. So formation of 4-digit number, 5-digit number, 3-digit number with the certain conditions, with a given condition. So formation of numbers with digits without repetition. Now let us take the first one. In this one, case 1, when there is no restrictions. So if the restrictions is not allowed, then let us move on to a problem based on this. When there is no restriction means, let us take an example. How many different 4-digit number? 4-digit numbers. You have to make 4-digit number can be formed using the digits 1, 2, 4, 5, 7, 8, 9, no digit being repeated. Repetition is not allowed. So, what is the problem given? How many 4-digit number? So, 4-digit number we are going to make. This is unit place, 10th place, 100 place and 1000 place. So, these are the 4. Unit, 10, 100, 1000. How many 4-digit numbers can be formed using, what are the digits given? 1, 2, 4, 5, 7, 8 and 9. How many digits are there? 1, 2, 3, 4, 5, 6, 7. So 7 digits are there. So here the 1000 place can be filled by the 7 numbers. All the 7 numbers can be kept in 1000 place. And the remaining, how many are left? So remaining out of these 7 numbers, 1 is taken, then the remaining 6 can be filled in 100 place. Again, if you take one more element from this, the remaining 5 can be filled in 10th place and the remaining 4 can be filled in unit place. So here 7 numbers can be filled in 1000 and 6 numbers can be filled in 100 place and 10th place can be filled by 5 numbers and the 4. So in this way we are going to arrange the required permutation. Therefore the required permutation is equal to so multiply this 7 into 6 into 5 into 4. That's all. So if you multiply, you will get the answer. This is the required permutation. What is this equal to? If you multiply this, you will get 840. That's it. See here, very simple problem. So how many different 4-digit numbers can be formed using the digits 1, 2, 4, 5, 7, 8 and 9, no digits being repeated. So here there are 7 numbers, 7 digits. So all the 7 digits can be first kept in 1000 place and the remaining 6 can be placed in 100 place and the remaining 5 can be placed in 10th place and the unit place can be filled by 4. So therefore the required permutation is equal to 7 into 6 into 5 into 4, that is nothing but 840 ways. This is how we are going to solve this problem. Very simple for 2 marks. Now let us take a similar type problem. Suppose problem number 2. How many 4-digit numbers can be formed with 1, 2, 3, 4, 5, 6, no digit being repeated? Here the condition is an even number. Here, how many 4-digit even numbers can be formed from the digits 1, 2, 3, 4, 5 and 6? How many digits are there? So number of digits is equal to, how many digits are here? 1, 2, 3, 4, 5 and 6. How many even digits are there? What are even numbers here? Even numbers is 2, 4 and 6. So that's equal to 3 even. So how many 4-digit even number can be formed from these without repetition? That is, no digit being repeated. Right, this is the given condition. So here 4-digit even number is to be required, is to be formed. So how many 4-digit even number can be obtained? So if an even number means it will ends with even number only. To 4-digit even number here is nothing but it will ends with even number only. So how many even numbers are there? 2, 4, 6, 3 even numbers are there. So the number which should be ends with only these 3 even numbers. So unit place, 10 place, 100 place, 1000 place. Here the unit place can be filled by 2, 4, 6. How many numbers are there? 3 unit can be filled by the even numbers 2, 4 and 6. So the remaining can be filled by 3, 4 and 5. That's it. So therefore the required permutation is equal to 5 into 4 into 3 into 3. 5 fours are 20 into 9. That's equal to 180. This is the required permutation. That's it. Hope you follow. So if a number ends with an even number, from this means it should end with these 2, 4 and 6 only. Therefore the unit place can be filled by the even number 3 and the remaining numbers 10th place can be filled by 3 and the 100 place can be filled by 4 and the 1000 place can be filled by 5. So therefore the required permutation is equal to 5 into 4 into 3 into 3, that is nothing but 180. That's it. Hope you followed. Now move on to the next problem. This is very important. How many 5 digits numbers can be formed with the digits 2, 3, 5, 7, 9 which are less than 30,000, greater than 70,000, between 50,000 and 90,000, greater than 75,000. So 4 conditions are given. Now less than 30,000 means 29,999. So that means here a 5-digit number. This is a 5-digit number, unit, 10, 100, 1000, 10,000. So this 10,000 place can be filled by only one number, that is 2. So only one number can be used to fill the 10,000 place, that is one digit can be taken, that is 2. And the remaining places 1000, 100, 10 and unit places can be filled respectively using the remaining numbers 4, 3, 2 and 1. That's it. Now what is the required permutation? So therefore the required permutation is equal to 1 into 4 into 3 into 2 into 1. That is nothing but 4 is a 12, 12 is a 24. This is the required answer for first one. That is less than 30,000 numbers or 24 numbers we can write using these digits which are less than 30,000. Now let us move on to the next one. Now this is also same as that of the previous problem. So greater than 10,000. Greater than 10,000 means we can take 70,000 and up to 90,000. So here 10,000 place can be filled, unit 10, 100, 1000, unit 10, 100, 1000, 10,000. See, greater than 70,000. Greater than 70,000 means we can make use of these two numbers, that is 7 and 9. So that means the 10,000 place can be filled by the two numbers 5, that is 7 and 9. This can be filled by 7 and 9. The 10,000 can be filled by 2 digits, whereas in the previous case it can be filled by only 1 digit, that is 2. The remaining can be filled by 4 into 3 into 2 into 1. That's all. So what is the required permutation? So therefore the required permutation is 2 into 4 into 3 into 2 into 1. That is 3 2s are 6, 6 4s are 24, 24 into 2 is 48. So the required permutation is 48. That's it. Hope you followed. Okay. So here the unit, the 10,000 place can be filled by only 1 digit, that is 2. Here the 10,000 place can be filled by 2 digits because it is greater than 70,000 means up to 90,000, that is 7 and 9. So therefore the required permutation here is 48. In the previous case it is 24. That's it. Now move on to the third one. This is also same as that of the second case. Between 50,000 and 90,000 means above 50,000 up to 90,000. So that is nothing but we can make use of 50,000 and above 50,000. 50,001. So therefore we can make use of these two numbers the 10,000 place can be filled by 2 digits. That is, I'll write here C, between 50,000 to 90,000. So here also unit, 10, 100, 1000, 10,000. So between 50,000 to 90,000, the 10,000 place can be filled by 2 digits and the remaining can be filled in 1000, 100, 10 and unit places like 4 into 3 into 2 into 1. So therefore the required permutation is 2 into 4 into 3 into 2 into 1. This is equal to 48 as that of the previous problem itself. Now case number 4. What is case number 4? Greater than 75,000. Greater than 75,000. So 75,000, 5 digit number 1, 2, 3, 4, 5. Unit, 10, 100, 1000, 10,000. Okay. In this problem, there are 2 cases arise. The first case, case number 1, case 1. Suppose if the first digit is 7, that means first place, the unit place can be filled by 1 digit, that is 7 by 1 time, and the second place, that is the 10th place, can be filled by, so in 2 ways. So the 10th place can be filled by 5 and 9 in 2 ways. So, and the remaining places can be filled by the remaining numbers, that is nothing but 3 and 2 and 1, that is 3, 2 and 1. So therefore the required permutation is 1 into 2 into 3 into 2 into 1, 3 2s are 6, 6 2s are 12. This is case number 1. In case 2, suppose if the unit place, if the first case 2, in case 2, first number, that is unit digit, is filled by 9. If the unit digit is filled by 9, that is one number, that is 9, unit, 10, 100, 1000, 10,000. The unit digit is filled by one number, that is 9. Remaining digits can be filled by the remaining numbers 2, 3, 4 and 1. So the required permutation is 1 into 4 into 3 into 2 into 1. 3 2s are 6, 6 4s are 24. This is the required permutation. That's it. This is how we are going to solve this problem. Hope you followed. Right. So here, therefore, what is the problem given? Greater than 75,000 means just add these two. Therefore, the number of digits found greater than 75,000 is, therefore the required answer is equal to 12 plus 24, that's equal to 36. 36 ways we can form the number greater than 75,000. Okay, hope you followed. Now, move on to the next problem. How many 4-digit numbers can be formed with the digits 0, 1, 2, 3, 4, 5, 6, digits not repeated? So what is the condition given? How many of them are odd and how many of them are divisible by 5? Right. How many 4-digit numbers can be formed with these letters? Let us find out how many 4-digit numbers can be formed with this. So 4-digit unit, 10, 100 and 1000. So a 4-digit number with these numbers 0, 1, 2, 3, 4, 5 and 6. Now, so we cannot keep 0 in the 1000 place. If we put 0 in the 1000 place, that is, then it will become 3-digit number. 3-digit number is not a 1000 number. So you can't put 0 in the 1000 place. So here 0 cannot be put. Then remaining, how many are there? 1, 2, 3, 4, 5, 6. So the 1000 place can be filled by 6, remaining 6 numbers. Then in other places, in 1000, in 100 place, 10th place and unit place, you can include 0. So therefore the remaining places can be filled by 6, again 5 and 4. So this is the required permutation. So that is 4-digit number with number 0, 1, 2, 3, 4, 5, 6 can be formed is 6 into 6 into 5 into 4. So what is this equal to? So this is equal to 6 into 6 into 5 into 4. This is 720 ways first. Now move on to the case 1. What is case 1? So here the odd numbers are, let us take the odd numbers 1, 3 and 5. So the unit place can be filled by these 3 odd numbers, that is unit, 10, 100, 1000. How many are there? 3 odd numbers. So unit place can be filled by the 3 odd numbers by 3 ways, right? The remaining places can be filled by the remaining. So 0 is also included. Therefore, we can't, the 1000 place cannot be filled by 0. So what are the numbers left then? 1, 2, 3, 4, 5. So the remaining 4. So in the 100 place we can include 0 also. Therefore, the remaining 100 place can be filled by 5 and the 10th place can be filled by 4. So therefore, the required permutation is 5 into 5 into 4 into 3. 5 5s are 25. 25 into 12. What is this equal to? So that's equal to 25 into 12 is 300. That's it. 5 5 4. See here? Very simple. How many of them are odd? The unit place can be filled by the 3 odd numbers and the remaining places 10th, 100 and 1000. So in the 1000 place we cannot put 0. So therefore, the 1000 place can be filled by the remaining 5 numbers and again in the 100 and the 10th place we can include 0 also. We can place 0. So therefore, the 100 place can be filled by 5 and the remaining 10th place is filled by the remaining numbers 4. So therefore, the required permutation is 5 into 5 into 4 into 3, that is nothing but 300. Case number 2, how many of them are divisible by 2? So case number 2, how many of them are divisible by 5? So here unit 10, 100, unit 10, 100, 1000. So here the digits are 0, 1, 2, 3, 4, 5, 6, right? Divisible by 5 means, that means here the unit place can be filled by 5 or 0. The unit place can be filled by 0 or 5, which is in 2 ways, right? Now here also 2 cases arises. Case number 1. In case 1, if the last digit is 5, last digit is 5 means, so the last digit can be filled by 1 way. The last digit is 5, right? And further, the 1000 place cannot have 0. So therefore, this 1000 place can be filled by 5 and the remaining 110 place can be filled by 5 and 4. So therefore, the required permutation is equal to 5 into 5 into 4 into 1. That is 5 into 5 into 4 into 1. 5 5s are 25 into 4, that's equal to 100, which is the required answer. Now come to the case 2. In case 2, so in case 2, if the last digit is 0, so in the first case, if the last digit is 5, in the second case, if the last digit is 0, so that means here the unit digit can be filled by 1 and the remaining 6, 5 and 4. So the remaining places can be filled by 6, 5 and 4. So therefore, the required permutation is 6 into 4 into 5 into 1. That is nothing but, what is this equal to? 120. Right. Therefore, the total number of digits which are divisible by 5 is, therefore, the total is equal to, so 100 plus 120, that's equal to 220. So therefore, the total digits which are divisible by 5 is 220. That's it. Hope you followed. Now listen to the next problem, same as that of the previous problem. How many numbers between 300 and 3000? Between 300 and 3000 can be found with the digits 0, 1, 2, 3, 4 and 5. So how many numbers between 300 and 3000 can be found with the numbers 0, 1, 2, 3, 4 and 5. So 3-digit number here greater than 300, that is 3-digit number, unit, 10 and 100. So first case, so that means which is 300 less than x less than 3000. So that means here the 100 place can be filled by 3 digits and the 10th place can be filled by 5 ways, right? 5 ways, and the remaining unit place can be filled in 4 ways. So therefore, the required permutation is 3 into 5 into 4. 5 4s are 20, 20 into 3 is 60 ways, right? Now 4-digit number less than 3000. 4-digit number. So this is 3-digit number, this is 3 digits and this is 4-digit number. So here 4-digit number means unit, 10, 100 and 1000, right? Now here also the 1000 place can be filled by two ways. The 1000 place can be filled by two ways, and the remaining 100, 10th and unit case remaining places can be filled in remaining 5, 4 and 3. So therefore the required permutation is, so 2 into 5 into 4 into 12. 4 is a 12, 12 5 is 60, 60 into 2 is 120. That's equal to 120. So therefore the total numbers between 300 and 3000, between 300 to 3000 total is equal to, so what is the first answer? 60. Second answer 120. Totally it is 180 ways we can fill. So therefore 180 ways we can fill these numbers, we can form between 300 and 3000. Okay, hope you followed. Now move on to the next problem. How many numbers can be formed with the digits 2, 4, 6, 8? How many numbers? So let us write the first unit number. So that is single digit. So we can fill the single digit by all these 2, 4, 6, 8 in 4 ways. The two digit number can be filled 2 digit. So first 4 and the remaining 3. So this is equal to 4 multiplied 4 into 3, that is 12 ways. This is 4 ways and 12 ways. And the 3 digit numbers can be formed 3 digit numbers. So first 4, then 3 and the remaining 2. That's equal to 4 into 3 into 2. 4 is a 12, 12 2 is a 24 ways. And the 4 digit numbers. So the 4 digit number can be formed using 4, 3, 2 and 1. What is this equal to? 4 into 3 into 2 into 1. That's also equal to 24 ways. Right. So therefore the total number of ways is equal to, therefore the total number of ways, is equal to first 4 plus then 12 plus 24 plus 24. What is this equal to? 24 plus 24, 48, 48, 50, 60, 64 ways. That's it. Right. The how many numbers can be formed means 64 numbers can be formed without repetition with the 2, 4 and 6. First find out single digit number, 2 digit number, 3 digit number and 4 digit numbers. So we will get the total as 64 numbers. So hope you followed this. These are few problems based on the repetition and non-repetition. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.